Welcome back to Safe Decode for our deepest dive yet into the science of fire. Everyone knows the basic fire triangle: heat, fuel, and oxygen, but that simple concept is incomplete. It explains how a fire starts, but it fails to explain how a fire sustains itself, and most importantly, how modern, highly effective extinguishing agents actually stop it. For that, we must understand the fourth crucial element: the uninhibited chemical chain reaction. We call this four-part structure the fire tetrahedron. Over the next 4 minutes, we will explore each of these four sides, their dynamic relationship, and the precise safety protocols required to remove them. Let's begin by revisiting the foundation. Side 1, the fuel source. The fuel is the combustible material: wood, paper, gasoline, or even metal. We know that fires are classified by their fuel: A, B, C, D, K, and the key safety protocol here is fuel removal. In a wildland fire, this is done by cutting fire breaks. In a structure fire, it might involve turning off a gas line. But here's the detail. The fuel isn't actually what burns. It's the invisible flammable vapors released when the fuel is heated. This brings us to side 2, oxygen. This is the oxidizer, typically the oxygen in the surrounding air. Fire needs a concentration of at least 16% oxygen to burn. The safety protocol here is smothering or oxygen dilution. When you place a metal lid over a grease fire, you're attacking this side of the tetrahedron by creating an oxygen-starved environment, a primary function of foam or CO2 extinguishers. Side 3, heat. Heat is the energy required to raise the fuel's vapors to their ignition temperature. Once a fire starts, the heat generated by the combustion itself sustains the process. The safety protocol is cooling. This is the oldest, simplest, and most common form of extinguishment, primarily done with water. Water absorbs the heat energy, converting it into steam, which removes the heat and stops the release of those flammable vapors, effectively breaking the cycle. Now we introduce the crucial side 4, the uninhibited chemical chain reaction. This is the complex chemical process that links the other 3 sides. When the fire is burning, the heat breaks down the fuel and oxygen into extremely reactive, unstable molecules called free radicals. These free radicals rapidly combine with the fuel and oxygen in a self-sustaining loop that produces more heat and more radicals, accelerating the fire. If you only remove one of the first 3 elements, the fire might briefly pause, but if the temperature is still high, the reaction can restart. This is where advanced extinguishers come in, and this is the most critical learning point. Agents like halon substitutes and modern dry chemicals, like those in an ABC extinguisher, are designed specifically to inhibit or chemically interrupt this free radical chain reaction. They don't just cool or smother, they chemically bind to the free radicals, neutralizing them and instantly shutting down the propagation of the fire regardless of the heat or oxygen level. They break the entire mechanism of combustion. Understanding the fire. Tetrahedron moves your safety knowledge from simply knowing what to do to understanding why you are doing it. It explains why a simple water extinguisher is insufficient for many modern electrical and chemical fires, and why a specialized agent that chemically interrupts the process is necessary for a complete and immediate suppression. This is the difference between a minor event and a major disaster. Thank you for spending this time with Safe Decode to master the ultimate scientific protocol of fire. If this detailed explanation has added value to your safety knowledge, please support our mission by hitting like and subscribe. Check the description below for links to our full series on extinguisher types and the PASS method, which applies this science in the real world.